In a previous video, we've looked at how to use synthetic division to divide two polynomials. We mentioned though that synthetic division does not always work. If what you're dividing by is not in this form where it's simply x plus or minus a number, you cannot use synthetic division. So instead we're going to have to take a stroll down memory lane, go back to elementary school, and revisit long division with polynomials. So let's take a look at how that works in this example. So I can see that synthetic division won't work. I'm dividing by a trinomial, it's x squared, like it breaks all the rules. So here's how this is going to work. First of all, take what you're dividing by. We're going to make this look like a long division problem from elementary school. So take what you're dividing by, and that's what gets written out front of the little division symbol thing, the little house thing. So we're going to start like this. What you're dividing into goes inside the house. So 2x to the third minus 5x squared. Make sure you notice for any terms that might be missing, and make sure that you're in descending order. This problem is going to be all about organization. We're going to see columns of numbers when we're done. X squareds are all going to be a column. X cubes are all going to be in a column. So neatness and organization is key in this case. All right, so to begin, what you're going to do is divide the first things together. By first things, I mean everything in front of both parts of this problem. So the 2x to the third and the x squared. So you may be able to do that in your head. I'm going to do that off to the side. I'm going to take the first thing, 2x to the third, and divide that by x squared. When I divide that, my exponents end up subtracting. I end up with 2 and there's x. So because that's 2x, I'm going to put that right above the other x in my division problem. I'm going to have columns of numbers when I'm done. So if you recall from your long division days, once you had that number on top, you then multiplied by what's in front. So let's take 2x and distribute to what's in front. So 2x times x squared is 2x to the third. Write that right below the other x to the third column, and those numbers will always match. Next up, we'd have 2x times negative 4x, which would be negative 8x squared. Notice our columns are starting to line up. And then 2x times 1 is plus positive 2x, okay? At this point, if you recall from your long division days, we're subtracting. Now, I don't like subtracting, so I'm going to change all my signs and just add things up. So make that a negative, make that a positive, and make that a negative, and just add. Your first two will cancel out. They always will. We wanted that to happen. Okay. Next up, we have negative 5x squared plus 8x squared. That gets us 3x squared. We've got positive x plus negative 2x, so negative x. And if you recall, our next step was to bring down the next term, so minus 10. Okay. Now we repeat the process all over again. So we're still dividing the numbers in front. Well, since those numbers got canceled out previously, my new number in front's right there, the 3x squared. So again, you may be able to do this in your head. Otherwise, off to the side, I'm going to do 3x squared divided by what's in front over here, which is still that x squared. That's going to divide out to just a 3. Okay, so that number gets written on top, and this time I'm going to write it above my constant column. So a 3. Since it's positive, I'll put a plus sign in front of it. Take that 3 and distribute it to what's in front. Multiply by what's in front. So 3 times x squared is 3x squared. Write it below the other x squared column, and those numbers will always match up. We wanted them to cancel out. 3 times negative 4x is negative 12x. And then 3 times 1 is positive 3. I need to subtract those numbers, so I don't like to subtract, so I'm just going to add the opposite. So make it a negative, make it a positive, make it a negative. You don't have to do that step, but I definitely like to because I don't like subtracting. So negative x plus 12x is 11x. Negative 10 plus negative 3 is negative 13. And there's nothing left to bring down, so that number must represent my remainder. So I can go back to my original problem. Just going to draw a line to separate my work there. My remainder is, I've got, remember we're not doing r, 11x, all that stuff. I have 11x minus 13 pieces out of what I was originally dividing by, which was x squared minus 4x plus 1. And I need a sign in between my constant and my remainder, so I'll put a little plus sign in between there. And that's going to represent my quotient using long division. Pretty fun, right?